Hello, good people. Welcome back to video two. Video two, we're going to continue working with piecewise functions. We're actually going to do E and F, which have to do with our function g of x, and G and H, parts G and H, which have to do with function h. So let's get going here. We are looking to find the limit of g of x as x approaches 1. So remember the statement from video one. The limit will exist if the limit from the left side matches the value of the limit of the right side. So let's figure this out. So that means I need to see what is the limit of g of x as x approaches 1 from the left. And I need to check what is the limit of g of x as x approaches 1 from the right. Because if these two answers match, then that's the answer to letter E. Okay, let's figure it out. This first one, x's that are approaching 1 from the left, that means my x's are less than 1. I'm looking at this part of the piecewise function. For x's that are less than 1, that means they're on the left side of 1. We can use direct substitution to evaluate what the limit value is going to be. We're going to substitute the value that the x is approaching and then just figure it out. So this is going to give us 3. And we do the same thing with the bottom. So the bottom, we're looking for the limit of g of x as x approaches 1 from the right side. Well, on the right side, those x values are bigger than 1 on the number line. If you think of the number line, that means I'm using this. For x's that are bigger than 1, those are to the right of 1. So I'm going to use that formula. Notice that wherever there's a variable, I'm leaving a space, an open parentheses space there, because then I'm going to plug in the x value that we're approaching. 5 times 1 minus 3. Well, 5 times 1 minus 3 is, 5 times 1 minus 2. And 5 times 1 minus 2 is 3. Hey, the left side equals the right side. So therefore, the actual retail answer to this limit is 3. I know this without knowing what the graph looks like. I know what this answer is because I checked the limit on the left side, I checked the limit on the right side, and they were equal. That means they're going towards the same place, so therefore the limit exists. If I got different numbers, that means I would have a graph that looks like this, right? But letter F is, again, different. This is asking what is the actual y value, the function value at x equals 1. Well, at x equals 1, it tells me the function value is 5. And we're done. All right. If you have questions on E or F, bring them to class, or you can watch it again and see if it makes sense the second time. But let's go to G. We're going to focus on function H, and then that'll end video 2 here. We're looking at function H. Let's use purple. So this is saying, in order to figure out whether this limit exists, I need to know, does the limit of h of x as x approaches negative 3 from the left side, first of all, does that limit exist? And then is it equal to the limit of h of x as x approaches 3 from the right? I'm sorry, negative 3 from the right. So I need to check both directional limits, the left-sided limit and the right-sided limit. So let's start with this one. If I'm coming from the left side, oh, well, what do I do here? It says, I'm going to use this top function if x doesn't equal 3, but I'm going to use this bottom value if x does equal 3. If I'm getting closer and closer to negative 3, if I'm getting closer to negative 3 from the left side, are those x values negative 3, or are they not negative 3? Obviously, we have to use the top. because all the x's that I'm getting closer and closer to negative 3 from the left, but all those x's are not negative 3. So therefore, I'm going to use the top one, and if I use the top one, it'll look something like this. Dang! What does that equal? Well, the top is going to equal 0, and the bottom is going to equal 0. What the heck? There's a 0 on top and a 0 on the bottom. How does that work? Well, the answer is this is an indeterminate form. I can't determine what's going on. This is what we call an indeterminate form because when I substitute 0 into the numerator in order to evaluate the top limit, I get 0. When I do so on the bottom, I also get 0. So it's kind of hard to tell, is this value getting smaller because of the 0 on top, or is it getting infinitely large because of the 0 on the bottom? And so we're going to have to find another way, and that is what next week is about. When we run into this indeterminate form, can I figure out what that is? So I'm going to pause letter G, and we're going to come back to it next week. But what about letter H? Is that doable? Can we find h of negative 3? Can we find the y value at x equals negative 3? Well, yes, right here. At x equals negative 3, it says the y value is 0. So I'm not sure how I'm going to find the limit on letter G, part G, but the function value for part H is solvable. We'll come back to indeterminate forms in another video.